Hello guys, good morning. Today's video is very important for you because now today I am going to solve this very suspicious fault. It is BLOD and called in detail blue screen of death in PS3. So guys, watch my full video so that you can make it understand how we can detect its fault on motherboard at component level, and what are the details of this fault, and in different motherboards what can we do to fix it. So let's start our video. Here is the PS3. If you can see the screen, I'm going to connect power cable and HDMI cable, and now I will turn it on. It is on red light. And here you can see the display. Now I'm going to connect the controller. We will just fix this here. Enter, back, and now you can see on the screen that this is a blue light of death. So guys, let's diagnose its fault, and let's see how can we fix it. Let's open it. And it shuts off with 2 beeps and still blinking green light. Okay, let's open it, and green light is not going to stop. Okay, I'm removing its power, and let's open it. Now let's check for it, and first of all I will tell you that it is an assumption that this fault relates with this Ethernet chip, this chip, but in my experience I have never detected a faulty chip for this fault. The first thing to understand is that how this fault occurs, or how this fault generates in PS3 board. It is because of the communication between South Bridge and Ethernet chip is bad, or this Ethernet chip is not working, or it is not working due to many reasons. But today I will tell you one of the reason about this fault. So first thing to understand that this board is I think 2500 CH2500. If you can see some other model, it is like some other model. This board is DYN001, as you can see, and this one is where is its, yes, JST001. And the difference in the circuitry of this fault is that, as you can see, there this Ethernet chip has no circuit like a crystal installed on these points, but this chip is getting clock from some other source, and on the other board, as you can see, that here is the chip is installed. The crystal diode is this crystal oscillator is installed, and it's mean that this chip is getting clock from some other source. As compared to this board, it is getting clock from this crystal oscillator that is installed on this board. So guys, we need to test all of its components. I mean to say that the coupling resistors that are connecting its output data to this south bridge, these are the resistors 1 2 3 4 5 6 7 and 8. So let's check for our faulty board. Here you can see, and here you can see the data coupling resistors. These are the resistors 1 2 3 4 5 6, and these are the two. These resistors are valued of 10 ohm. Let's check it. It is 10. Yes, 10, 10, 10, and 10, and 10. We should check these two. It is also 10 ohm and 10 ohm. So the communication between this Ethernet chip and the south bridge is good. Now we will check for the reason that how this fault is generating in this board. We have to power it on. For this I need ground. And the power. And here are the cables. And the on off switch strip should be attached so that we can turn it on. And we need not to connect the HDD here because we are checking it on component level. So I have to set this camera so as you can see both the oscilloscope and the board. Now I will check the the board. Here we need to check that first turn it on, and the scope should be in analog mode. Now I am going to on it. And check for the clock on this capacitor. It is turned off. Oh my god, I have put this check reverse polarity in reverse polarity, but there is no problem. It will not. Let's check it again. I'm going to turn it on. We need to check clock signal on this capacitor. This is the coupling capacitor. If I can show you closely, this one is the coupling capacitor that gives clock to this chip. I think it is the 29 number, pin number 29, where it goes on this chip. So if you can see oscilloscope as well. Now I am going to turn it on. Yes. And now here we will check for this clock. It is not giving any clock, and the output goes to this point. Here is also no clock. So we need to find out the clock that should be here. What is the source of this clock? For this, we need our multimeter. It should be on ohm, and we should set its 0 value. It's fine. And now let's take all the parts from it away. Now I will check its. We should set it on beep mode, and if you can hear it, my beep meter's beep is very low. If you can hear it, yes. So guys, the source from these resistors, the point is going to this hole. This is the hole, and at the back side of this board we can find the hole, this one. I'm sure it should be like this. No, it is here. It is in third layer. So according to my experience, here is the chip that is connected with a crystal oscillator. The clock must be generated by this chip, and forward to the Ethernet chip. For this we must keep this point, one of the probe on this capacitor, and move to our back side. Yes, as you can see that we will check for these resistors. No, no, no. These are the resistors of value 47 ohm. And yes, here it is. As you can see, the beep. It means this clock is the source, and this is the coupling resistor for the Ethernet chip. So we must check for its value. Its value should be of 47 ohm or 33 ohm. Let's check it. Here it is, and oh yes, as you can see, it is giving the value 268 kilo ohm. It is not good. And the other resistors are 43 ohm, 43 ohm. It's good. And this one is 43 ohm. Yes, it's fine. And now we have detected this resistor. Now we need to change the resistor. This one, that is the coupling resistors through which the clock output from this chip goes to the Ethernet chip. So let's try to change it. For this I need donor board. I have one, and we need this one. This resistance we need, it is going to the Ethernet. It is green color. The first one was black, and now we will test for the clock output. I have connected the powers, standby power, 12 volt power, and the on off strip. So now let's check for its. I'm going to turn it on, and here we will check for the clock. I hope you can see the oscilloscope. Here we should I'm going to turn it on. Yes, here is the clock available now, and output is here. The test point is this, and the output for the south bridge clock is here, but is for an instant. I will let you check it again. The output of Ethernet, the output clock from this Ethernet for this south bridge is for some instant, and here is the output point, this one, and this one is the coupling resistor that goes to this test point. So we can check here and here and here. Let's check it again. First I will check it here. Everything will be verified. This test point, yes, as you can see the clock is in order. Now we will test it after fixing it on its fan and heatsink assembly. And let's assemble it again. Standby board, 12 volt power strip, hard disk is connected, HDMI MI cable is connected, and the remaining thing is our controller. It is also connected. Now I'm going to turn it on. First I will power on from here, and now it is on standby light, and now I will turn it on. Yes, let's see either our fault is fixed or not. Hopefully it is fixed. Now go to the display. And here we set only for this year and enter. Here I can cancel it. Yes, now there is no more blue screen of death sign. So guys, thanks for watching my video. If you like it, please subscribe, and hopefully I will give you more informative videos for you. Thank you very much. Goodbye.